Okay, area is going to be similar to what we just did a while ago. First of all, I'm going to write area of the entire circle. You don't have to put that word entire. I just want to emphasize that. Area is pi r squared. Okay, that's the area of the entire circle. What I'm going to find here is the area of the sector, which means the section here that's shaded. Can't really tell that's supposed to be shaded, but it is. All right, so I'm going to do this just like I did the arc length. I'm going to look at this when my theta is in degrees, and I'm going to look at this where my theta is in radians. My area is the fraction of the circle times pi r squared. Right? It's the same whether I'm looking at degrees or radians. The fraction of the circle times pi r squared. Now here, if I'm in degrees, it's just going to be that angle theta over 360 degrees. When I'm in radians, I have theta over 2 pi times pi r squared. And what happens is that the pi's cancel. And normally what they do is they rewrite this to where this 1/2 is up front and then r squared theta at the end. So this is my formula for the area of a sector.
Okay, we're going to use the formulas that we just discussed to do a couple of problems. The directions say to determine the area of the sector in terms of pi, then round your answer to 2 decimal places. Problem 1, a circle has a radius of 4 feet. Find the area of the sector formed by a central angle of 60 degrees. Okay, this is the formula I'm going to use. I'm trying to figure out what the area is. I know the radius is 4. Now it's very tempting here to put 60 degrees in place of theta, but remember that this formula is for when theta is in radians. So I need to change 60 degrees to radians. Now I can do this in my head. 60 divided by 180, that's 1/3. So I have 1/3 pi or pi over 3. But if you had numbers here that weren't quite so easy to do in your head, what I would do on my calculator is 60 divided by 180 without the pi, figure out that fraction, and then just stick the pi on the end of your answer. And again, here, if you needed to put this into the calculator, I would put all of this in the calculator without the pi symbol and then just stick the pi on it at the end of your answer. I can actually do this in my head quicker than I can put it in the calculator. 4 squared is 16, half of 16 is 8, so I have 8 pi over 3. And my units here is feet squared. So I can put all of this into the calculator to get a decimal approximation. Do approximate symbol there. So I have 8.38 square feet. I'm going to skip over problem 2 because it is just like problem 1. Problem 3, the area of a sector is 36 square feet. The radius is 6. That should say 6 feet. Determine the angle of the sector. I always like to write down my formula every time I'm using that. On this problem, I know what the area is. It is 36. And I know what the radius is. It's 6 feet. Now for this particular problem, actually I know that 6 squared is 36, so I could probably do a shortcut here because I have 36 on both sides of my equation. But I'm just going to go ahead and multiply this out. 1/2 times 6 squared is 18. So from here, I divide both sides of my equation by 18, and I get theta to equal 2. So the angle of that sector has a measure of 2 radians. Now, if I wanted to, I could go ahead and multiply this 2 radians by 180 over pi in order to change it to degrees.